Hey guys, welcome to our first lecture. This is going to be on chapter 6, module 18. And we're going to go ahead and get started and hopefully have a little bit of fun and learn some stuff at the same time. All right, so go ahead and start sharing the screen and pull up the PowerPoint. So this chapter is on population and community ecology. What we're going to be talking about here is pretty much population dynamics, or how populations change in ecosystems. We will, in the next chapter, talk about humans, and we'll relate a little bit to humans in this chapter, but this is more on ecosystem populations and ecosystem communities. All right, so Module 18 is on the abundance and distribution of populations, and after talking about this and reading this in the textbook, you should be able to explain how nature exists at several levels of complexity, discuss characteristics of population, and contrast the effects of density-dependent and density-independent factors on population growth, which we'll get into. All right, so what is a population? We're going to talk about different levels of complexity within an ecosystem. So population are the individuals that belong to the same species and live in a given area at a particular time. So this would be all the same species of plant or animal. Community is going to be all of the populations of organisms within a given area. So all the different populations, all the different species within an ecosystem or a certain area would make up the community of that area. And then the study of all of this, the study of those dynamics, of those changes, is called population ecology. So you can see here a visual representation of the levels of complexity from the least complex, which is, of course, an individual. All the different individuals of the same species make it more complex, and that's a population. In that area, all the different populations, you can see the trees, you can see the grasses, you can see the bunnies and the wolves. That's all part of a community. A bunch of communities together are the ecosystem of that area, and finally combined all the ecosystems on Earth is what makes our biosphere, or basically this unit. All right, so the 5 basic characteristics of a population of the same species are this big N. All right, if you ever see that in an equation, that's just the number of individuals in a population in a defined area. Individuals of the same species, the population size. The population density, all right, is going to be equal to that N value divided by the amount of area that they're living in. So density, kind of like how you have density in chemistry, which is mass per unit volume. In ecology, your population density is going to be the number of individuals in a certain area. The population distribution is something we talked about in the last unit when we talked about what makes things good and biodiverse and healthy in an ecosystem. We talked about how not only that there need to be a large number of individuals, but there also need to be evenly distributed. So that's a description of how individuals are distributed with respect to one another. The sex ratio is the ratio of males to females in a population. That's important for how the population reproduces. And the age structure is a description of how many individuals fit into a particular age categories in a population. So what proportion are 0 to 5 years old? What proportion of the population are 5 to 10? So on and so forth. That's huge when we talk about human populations, especially. So that will be big in the next chapter, will be the age structure. So population size is affected by density dependent and density independent factors. All right. So factors that influence population size are either density dependent or density independent. So they either depend on how big the density is, how many individuals there are in that certain amount of area, or they don't depend on that at all. The factors would be independent of how many individuals are there. So density dependent factor is a factor that influences the individual's probability of survival and reproduction in a manner that depends on the size of the population. So this is, if you talked about humans, this could be something like what we're experiencing right now. if the COVID-19 coronavirus is in a large populated area, that affects how quickly it can spread and how many individuals it can impact. This whole thing with social distancing or physical distancing, I guess is what they're calling it now. It really makes sense because of this. So we're trying to take individuals and make them less dense in terms of how much they're in contact with each other, which should slow and minimize the impact of the virus. So that would be a density dependent factor. A density independent factor is a factor that has the same effect on the individual's probability of survival and amount of reproduction at any population size. So it doesn't matter how many are in there. These are things like natural disasters, like a hurricane. A hurricane doesn't matter if there's a million animals or trees or people in the area. It's going to pretty much have the same effect. This could be, again, another natural disaster, like an earthquake. Earthquake doesn't matter how many individuals are in the population, or a fire, or anything like that. Those don't really depend on how many are there. These factors will influence the population that way. And that's it for Module 18. So you will need to read and listen to Module 19 for the first assignment, but I'm going to do these one module at a time. Thanks.